The subsonic ramjet, also known as an etodid, an aerothermodynamic duct, is an air-breathing subsonic jet engine in the form of a continuous duct that uses the engine's forward motion in conjunction with its shape to compress incoming air. Fuel is added to the compressed air, ignited, and the resulting hot gas accelerated through a nozzle, producing thrust. Ramjets can be particularly useful in applications requiring a small and simple mechanism for high-speed use, such as rockets. This concept lay essentially dormant until World War II, at which time two German scientists, Eugen Zenger and Irene Brand, realized that by using a high combustion temperatures in a subsonic etodid, particularly unlimited performance with fuel consumption values between gas turbines and rockets might be possible. Approximate performance calculations for a subsonic ramjet installed in a fighter indicated that the aircraft could, after a rocket-assisted takeoff, climb to an altitude of 18,000 meters in 3 minutes and fly at a speed of 900 kilometers per hour. Eugen Zenger was an Austrian aerospace engineer and Irene Brand was a German mathematician. Starting in 1942, Zenger and Brand became interested in the performance possibilities of the subsonic etodid. The initial results were encouraging, so they embarked on more detailed calculations which validated the approximate calculations. The theoretical predictions were so favorable that Zenger and Brand sought to confirm the results experimentally as soon as possible. Since there was a growing threat from Allied bombing attacks, the tests were planned so that they could be accomplished rapidly and results applied directly to a flying version. Therefore, time-consuming construction of stationary test stands were never considered. Instead, testing up to 25 meters per sec aboard a road truck, which they called towing tests, was adopted. The lesser accuracy of towing tests was outweighed by the advantage of fresh air conditions, especially in regard to turbulence, air density, and moisture. The towing tests also allowed Zenger and Brand to validate that the desired temperature conditions could be created, that the dimensional proportions were correct, and that the combustion chamber walls were robust enough to handle the temperature. Through careful pressure measurements, the team validated that the 10 degrees diffuser angle was optimal and nozzle dimensions were satisfactory. This particular etodid was mounted atop a Dornier DO-17 bomber for a total of 70 flight tests at speeds up to 100 meters per sec, and each test lasted about 3 minutes. The mounting scheme allowed measurement of thrust and drag, as well as pressures at various points within the etodid. These tests again confirmed the calculated performance and highlighted the importance of correct fuel and air ratio in achieving maximum efficiency. Another etodid was mounted atop a larger Dornier DO-217 bomber, which provided testing speeds between 100 and 200 meters per sec. The Dornier DO-217 was a bomber used by the German Luftwaffe during World War II. It entered service in early 1941 and by the beginning of 1942 was available in significant numbers. The Dornier 217 variants were more powerful than the contemporary Heinkel 111 and Junkers Ju-88, having a greater speed, range and bomb load. The team measured thrust, fuel consumption and pressures at various points within the atodid while observing the combustion process. The Dornier with the atodid attached was capable of obtaining a speed of 90 meters per sec in horizontal flight, with the atodid running speed increased to 120 meters per sec. A series of increasingly steep glides achieved the higher speeds. The limiting speed was reached when the Dornier elevator control reached the limit of its authority to counteract of nose-down moment resulting from the increased thrust from a high-mounted atodid. Zenger and Brand envisioned that such a test aircraft could be towed to an altitude of a few thousand feet, whereupon both the tow plane and test plane would dive, thereby achieving a velocity that would start the atodid and raise its thrust to a sustaining value. Such a test aircraft, complete with a pressure cabin, was under construction during October of 1943 when the report was written, but there is no evidence it was ever completed. Several atodid-powered applications were suggested, including airplanes, armor-piercing bombs, glide bombs and torpedoes. However, the most promising application was in various airplane power plants. High-altitude operations would begin with takeoff and climb to an altitude that would give it air superiority at a speed of about Mach 0.9. theoretically as high as 20,000 meters. Its range and endurance would depend on the operating altitude and speed. For example, at 12,000 meters and at Mach 0.9, the aircraft would have sufficient fuel to fly for 3,000 seconds, giving it a range of 870 kilometers. Better endurance and range were achievable at lower speeds. This combination of rapid climb to altitude and ability to loiter made it ideal for anti-bomber roles at altitudes ranging from 8,000 to 18,000 meters. But from the middle of 1944, every available drop of aviation gasoline was reserved for Germany's defense efforts. Zenger and Brand attempted to substitute pulverized coal, but this was not successful. The combination of fuel scarcity and the waning Luftwaffe support brought an end to all these experiments. But Zenger and Brand remained active in the European aerospace community even after World War II. I hope you enjoyed this episode, and make sure you don't miss my future work. Please make sure you are subscribed to my channel and press the bell notification button. Thank you and see you in the next video.